everyone, I'm Ava. Today we're going to be going over the AMC 2025 problems. And so the first problem, it tells us that the 8-pointed star shown in the figure below is a popular quilting pattern. And what percent of the entire 4x4 grid is covered by the star? So if we look at this grid, we'll notice that there's a few main parts that it's made up of. First is there's a square in the middle, and then you have these half squares, like half of the squares. So something we can do here is we just split up this shape into the existing shapes that we know, which we have a square, right? And then that's 4. And then if we connect these two triangles, it forms one square. So it'll be an area of 1, 1, and 1. So we can add all of this up, and the total is going to be 4 plus 1 times 4, which equals 8. So we know the answer is 8 over 16, which equals 1 over 2, which is equivalent to 50% of the area is made up of this quilted star. So problem 2. The table below shows the ancient Egyptian hieroglyphs that were used to represent different numbers. So for example, the number 32 was represented by these symbols. And what number is represented by the following combination of symbols? So all we really have to do is we have to match up the different symbols with the key that they've given us. So for example, this first one is 10,000, and all of these are equivalent to 100. So if we just go like this, and then all we have to do is add it up. For example, 4 times 100 plus 2 times 10 and 3 times 1. So that would be equivalent to 10,423. So we know the answer is B, which is exactly the sum we got. Problem 3. Buffalo Shuffle is a card game in which all the cards are distributed evenly among all players at the start of the game. When Annika and her 3 other friends play Buffalo Shuffle, each player is dealt 15 cards. Suppose 2 more friends join the game, how many cards will be dealt to each player? So what we have to do here is we have to first find the total of how many cards there are, and then divide it by the new number of players, and that'll give us the new number of how many cards each player has. So something here you gotta be careful of is Annika and 3 of her friends. So that is equivalent to 4 people, not 3. So keeping that in mind, we can calculate the total as 4 times 15 equals 60 cards in total. And when 2 more of her friends join the game, she now has 6 players playing the game in total. So that's 60 times 6 equals 10. So the answer is C, which is 10. Problem 4. Lucius is counting backwards by 7s. His first 3 numbers are 100, 93, and 86. And what is his 10th number? So say you have some numbers here, and you have 10, right? So in the middle, you're going to have 9 different gaps. So what that means is basically, if you're counting to find the 10th number, you're jumping over 9 7s. So if he starts on 100, to find the 10th number, we subtract 9 times 7 from 100, which is 100 minus 63, which is 37. So the answer we get is B, 37. Question 4. Betty drives a truck to deliver packages in a neighborhood whose street map is shown below. Betty starts at the factory and then drives to location A, B, C, and then finally F. What is the shortest distance in blocks she can drive to complete this route? So notice here that taking these paths of this way, or going from the top, they are equivalent in distance. So the path between 2 locations is always equal no matter how you move. So what we have to do is, all we need to do is just find the possible distance between all of these locations, and then if we add it up, it'll give us the answer. So here we have 1 horizontally and then 2 vertically. And this is 3, and the bottom is 7. This is 4, and this is 2, and this is 1, and this is 4. So if we add all of that up, we'll get our answer. So 1 plus 2 plus 3 plus 7 plus 4 plus 2 and plus 1 plus 4. That comes down to 3 plus 10 plus 6 plus 5, which is equivalent to 24. Problem 6. These numbers 15, 16, 17, 18, and 19 are written down. After he erases one of the numbers, the sum of the remaining 4 numbers is a multiple of 4. Which number did he erase? So something we can do here is if we can find the whole sum of all 5 of these numbers, and then we find a way to minus one of them that will result in a multiple of 4, then we're able to take out which number is specifically that number that's being removed. So let's add up all of them first. So when we add up all of these, we eventually come down to a sum of 31 plus 35 plus 19, which equals 66 plus 19, which is 85. So then here we take the remainder, as that'll help us to find out more easily which number is being taken away. So as opposed to trying to try every number, this means that we are able to see the remainder is 1. So we need to take away a number that is also having a remainder of 1. So here we have our numbers all the way from 15 to 19. Right. So 5 is 12 plus 3, so it has a remainder of 3. 16 has a remainder of 0, 17 has a remainder of 1, and 18 has a remainder of 2, and 19 has a remainder of 3. So we know that the original remainder was 1, which means we now need to take out another number of a remainder of 1 to ensure that the final sum is a multiple of 4. So here that means we're taking out the number 17, and that means our final solution is C, which is 17. So question 7. On the most recent exam of this professor's class, 5 students earned a score of at least 95%, 13 students earned a score of at least 90%, and 27 students earned a score of at least 85%, 50 students earned a score of at least 80%. How many students earned a score of at least 80% and less 90%? So what this means is that if we drew this out in this tower kind of way, and we can split it up based off the different ranges that are given to us, where for example this would be 80 and this would be 85. For example, this would be 80, this would be 85, 90, and then 95. It means that 50 students earned a score of at least 80%, which means the total of this whole stack is 50. 27 students earned a score of at least 85%, so this is 27, this is 13, and finally this is 5. So if you want to find the number of students between each layer, we would need to calculate starting out with 5 at the top. 13 minus 5 equals to 8. And then 27 minus 13 equals to 14. And 50 minus 27 equals 27. So we want to find out how many students are larger than 80 but less than 90%. And so that would be 14 plus 23 equals 37. So the answer comes down to D, which is 37. Question 8. A cardboard cube is cut open to form a flat shape shown on the right, which is an area of 18 square centimeters. What is the volume of the cube in cubic centimeters? So if we write this down as an equation, we get, assuming that the side length is x, we have 6 times x squared equals to 18, which means x squared equals 3, and x equals square root of 3. And if we want to find the volume of the cube in the cubic centimeters, we know that the volume equals to x cubed, and that would be square root of 3 cubed, which is 3 times square root of 3. So the answer is A, which is 3 times square root of 3. Question 9. There are 6 pairs of numbers directly across from each other on a clock. She takes the average of each pair of numbers. What is the average of the resulting numbers? So since this is relatively easy to calculate, what we can do is we just write out each pair and then calculate their value. For example, it would be 12 plus 6 divided by 2, and then so on until we write out all of these pairs. So 2 plus 8 divided by 2, and then 3 plus 9 divided by 2. 4 plus 10 divided by 2, and then 5 plus 11 divided by 2. And so if we calculate that, we get 9, 4, 5, 6, 7, and 8. And now we don't actually need to add them all up and divide by 6, because if we order this from in ascending order, we get 4, 5, 6, 7, 8, 9. So we know that averages are basically the middle number. So basically we can put 6 plus 7 and then divide it by 6.5, since all of these are added up by an equal value. So the average of all of them is just the median. So the answer is B. Question 10. In the figure below, ABCD is a rectangle with side length AB equals 5 and AD equals 3. Rectangle ABC is rotated 90 degrees clockwise around the midpoint of side DC to give a second rectangle. What is the total area in square inches covered by the 2 overlapping rectangles? So they tell us that specifically this is a midpoint, and because we know that side length of DC equals to side length of AB, so it means that these are each 2.5. And the same thing is also a midpoint on this side, since we know it is rotated 90 degrees. So that's 2.5 as well. Now if we think back to a similar concept here, is a Venn diagram. Essentially, when you're calculating A and B and you're trying to find the union of A and B, which is written as this value, we find that through A plus B minus the overlapping area, which is this part, right? So we have to kind of subtract the overlapping area here, and this is the same logic. So the total area is 15, and so 2 15s, 15 plus 15 minus 5 over 2 times 5 over 2. So 30 minus 25 divided by 4 equals 120 minus 25 divided by 4 is 95 divided by 4. And so simply we can divide that to find our answer. Yep. So that means our answer is D, which is 23.75. Question 11. A tetromino consists of 4 squares connected along their edges. There are 5 possible tetromino shapes, which are shown below, and they can be rotated or flipped over. These 3 tetrominos are used to completely cover a 3 times 4 rectangle. At least one of the tiles is an S tile. What are the other 2 tiles? So for these types of questions, we only need to find out one possible solution, and we know that all the other solutions are going to be the same, since they only ask for one solution. So we can kind of be lazy here and just let's say we choose this and just try a lot of different ways. So obviously Obviously, we know that we can't put it like this because otherwise you can't put anything here. So we'd have to put it somewhere like this. And that would mean the other two shapes could be two L shapes, and that would fulfill the requirements. So therefore, we can choose answer C, which is L and L. Question 12. The region shown below consists of 24 squares, each with side length 1 centimeter. What is the area in square centimeters of the largest circle that can fit inside the region, possibly touching the boundaries? So if we translate this, the largest circle that can fit inside is essentially a circle with the largest possible radius. So we can try a few radiuses here. So first, the center of the circle has to be in the center of this shape to ensure symmetry, which will ensure we have the largest area. So let's assume we want to say the radius is like this, it's 3. However, if you notice here, if that was here, it would go outside of the shape. So we have to find a radius that is largest while also staying completely within the shape. So if you look here, we can have a radius that is like this, and that would fulfill at the same time all of these requirements, so it stays within the shape but it's also the largest. So we can draw that out now. The circle that would touch all of these sides. And to find the radius, all we have to do is see this is side length 1 and this is 2. So therefore, our radius equals the square root of 1 plus 2 squared, which equals square root of 5. And the area of a circle is square root of 5 squared pi, which equals to 5 pi. So the answer is C, which is 5 pi. Question 13. Each of the even numbers from 2 to 50 is divided by 7, and the remainders are recorded. Which histogram displays the number of times each remainder occurred? So what we can do for this type of question is, because they give us this ascending sequence from 2 to 50, we know that the remainders of 7 are going to just repeat and they're going to be cyclical. So if we can find how long each cycle is, then we can find out how many sets of these cycles there are across from 2 to 50, and that will allow us to calculate the number of times that every remainder occurs. So what we do here is we can write this out of 2, 4, 6, 8, 10, 12, 14, 16, 18, and then 20. Then write out the remainder below, remainder of 7. And then here 16 has a remainder of 2, this is a remainder of 4, and this is a remainder of 6. So we know that this is one cycle, and that each cycle is 7 long, 7 numbers. So since these are even numbers, you would imagine that between them they would have odd numbers as well. So when we're trying to find out how many sets of numbers there are within 50, we actually have to divide 50 by 14 instead. And this gives us 3 with a remainder of 8 numbers. And so we want to find out the remainder of 8 numbers. So we know it reaches out to 42 as a complete set. And the remaining numbers are 44, 46, 48, and 50. And those each have the remainder of 2, 4, 6, and 1. And so we know that 2, 4, 6, and 1, they each have 1 extra remainder, which means they have 4. So we just have to find the image here that matches that. So here notice this is 2, 4, 6, and 1. And so the answer is A. Okay, question 14. A number n is inserted into the list of 2, 6, 7, 7, and 28. The mean is now twice as great as the median. What is n? So we want to find out whether if we insert a number into certain locations, what the new median is going to be. So let's say here, if we inserted a number into the first slots before 2 or between 2 and 6, the new median is going to be 6.5. And the reason for that is when you do that, you would have like 1, 2, and 3 numbers, and that would be 6 plus 7 divided by 2 equals to 6.5. If you put it after 7 or after 28, you would have a median of 7, as the original order would not be changing, and you would have 7 and 7 as the third and the fourth number. So that gives us a few things. First is we can find the sum and then test each of these two medians to see which one is viable, and then verify what number would be required to be inserted, and then check if that matches the location we had. So let's add up all of these first. Sum equals 2 plus 6 plus 7 plus 7 plus 28. And that 8, 15, 20, 32. What? No. 22 and then 50. And so the total sum is 50. Now if we say that the median here is 6.5, that means the mean has to be 13. And with a mean of 13, it would be 13 times 6 equals 78. And so the number you need to put in, say it's x, is 78 minus 50 equals 28. Now that's not viable, since that would mean you would need to put it in like one of these areas. However, we already agreed upon that it would have to be within 2 or 6, so that is not correct. Therefore, we can test the second one. M equals 7. That means the mean is 14, and the total sum needs to be 14 times 6 equals to 84. That means x is 84 minus 50, which is 34. Now that is correct, since we can put it after 28 and the median will still be 7. So n, or the number we're looking for, is E, which is 34. Question 15. K draws a 6x6 grid. He colors 13 of the unit squares silver and the rest of them are gold. He then folds the grid in half vertically, forming pairs of overlapping unit squares. Let M and uppercase M equal the least and greatest possible number of gold-on-gold pairs. What is the value of the min and the max? Now, we have two graphs here. And for the minimum number of gold-on-gold pairs, what you want to do is you want to maximize the number of silver on gold pairs. So what that means is you want all the silver ones on one side. So you want silver on one side of this vertical line. And that means you can maximize the number of silver on gold pairs. So if you write that out, then we have 13 silvers. So this area would all be silver. And you'd only have 5 gold pairs. And this, all of it would be gold, which means you would only have 5 gold pairs. And to maximize it, you want to minimize the number of silver on gold pairs, which means you want to maximize the number of silver on silver pairs. So you put the silver evenly on both sides. Therefore, we would have like 6 silver on the left side, and then 7 silver on the right side. So then this one would be not viable, would not be a viable pair. And so we would have all of these as gold. If we count it up, that would account to 11 pairs. So in total, we have 16 gold-on-gold pairs. Question 16. 5 distinct integers from 1 to 10 are chosen, and 5 distinct integers from 11 to 20 are chosen. No two numbers differ by exactly 10. What is the sum of the 10 chosen numbers? Okay, so what does this question mean? Basically, if we had 10 of these numbers, and then we split it up along the middle, which is the digit 5, right? And then we would have that for both 1 to 10 and both like 10 to 20. That means that if you were to choose these in the pairs of like numbers, you would need to choose those that are separated. Either you choose the red pair or you choose the blue pair here. However, notice that either way, you're going to have the same sum because you have the same numbers of 10s digits and 1s digits. So either way, we can find the sum and it'll be the same. So you're going to have 5 numbers that have a 10s digit of 0, since they are the 5 numbers from 1 to 10. And you're going to have 5 numbers with a 10s digit of like 10, so that would lead to a value of 50. Meanwhile, for the 1s digits, you're going to have 1 all the way added up to 10, which we know equals to 1 plus 10 divided by 2 times 10, based off the arithmetic sequence sum, and that is 55. So the total sum of all these numbers is 50 plus 55, which is 105. And so the answer is C, 105. Question 17. In the land of Markovia, there are 3 cities, A, B, and C. There are 100 people who live in city A, and 120 who live in B, 160 who live in C. Everyone works in one of the 3 cities, and a person may work in the same city where they live. So, in the figure below, an arrow pointing from one city is labeled with the fraction of people living in the first city who work in the second city. So the first thing we can do is we can write out how many people live in each city. Now, think of these arrows as the number of people that are going to the other city to work each day. So it would be A is gaining 40 people from B and is gaining 20 people from C. However, they are losing 25 people and losing 20 people. So the number of people that work in their city is, therefore, first, the people that both live and work in A is 100 minus 25 minus 20. And the additional people that they get is 40 plus 20. So that equals to 55 plus 60, which is 115. So the answer is D. Question 18. The circle shown below on the left has a radius of 1 unit. The region between the circle and inscribed square is shaded. In the circle on the right, 1/4 of the region between the circle and inscribed square is shaded. The shaded regions in the 2 circles have the same area. What is the radius r in units of the circle on the right? So to find the radius r, what we can do is first we take the equation that they tell us of the equal area, and then we're able to find out what the r is. So we know here that this is also equal to 1, since it's also the radius. And we remember from the Pythagorean theorem that there is a 45, 90, 45 triangle with x on each of the legs and square root of 2 times x on the hypotenuse. So therefore that means, since here square root of 2x is equivalent to 2, it means that x equals to square root of 2. So therefore the side length of this square is square root of 2, and the overall shaded region is pi minus 2. Here this is also r, and so that's square root of 2r. And the overall area of this is pi r squared minus 2r squared divided by 4. So if we write out this equation, because they have an equal area, we get r squared times pi minus 2 equals 4 times pi minus 2. So r squared equals 4 and r equals to 2. Therefore the answer is B, which is 2. Question 19. 2 towns A and B are connected by a straight road, 15 miles long. Traveling from town A to town B, the speed limit changes every 5 miles, from 25 to 40 to 20 miles per hour. Two cars, one in town A and one in town B, start moving toward each other at the same time. They drive at exactly the same speed limit for each portion of the road. How far from town A to town B would the two cars meet? So they give us these distances. However, you want to find out where where they're gonna meet. So if you remember here that for these like speed and distance problems, there's a few main variables: speed, distance, and time. Now here they tell us already what the speed is and what the distance is, which means we only need to figure out time to essentially find out for this problem. So then we can find out for each like section how long it takes, and then find out in total how long it takes to travel this road, and then find like what half of the time is. So basically for the first section A, it takes 1/5 of an hour, since that's 5 divided by 25. For the next, it takes 1/8 of an hour, and then 1/4 of an hour. So now total time equals to 1/5 plus 1/8 plus 1/4, which is 8 plus 5 plus 10 divided by 40, and that's 23 divided by 40. So they meet at the time when it is 23 divided by 80, and then 23 divided by 80 minus 1/5 equals to 23 minus 16 divided by 80, which is 7/80. So what 7/80 essentially means here is that this is the remaining time that they will have to travel within this section. Because we know that car A, let's just say it goes this way, it's going to be traveling all of this, and then it reaches some point within section B. So here you notice that 1/8 times 7/10 equals 7/80. So therefore, it is traveling around like 70% of section B. So we just have to find out what is 70% of 5, and then add that to the existing length of section A that was traversed. So that is equal to 5 plus 5 times 7/10, which equals 5 plus 3.5, which is 8.5. And so the answer is D, which is 8.5. Okay, problem 20. Three people are sharing a large block of cheese. They take turns cutting off half of what remains and eating it. So first Sarika eats half of the cheese, then Dev eats half the remaining half, and then Rajiv eats half of the remaining half of that half. So, and then they pass it back to the first person, and so on. So essentially what this means is, and the question is asking us how much cheese does Sarika eat in total. So let's mark out the number of cheese that Sarika eats in red. So first she eats half of it. Then she passes it to the second person who eats a quarter, and then third eats 1/8. And so the next she eats like 1/16, and then so on. This goes on completely like infinitely, essentially, because they tell us here that they stop when the cheese is too small to see. What that means is it's an infinite like cycle, and they just keep eating cheese. So if we see the sum of how much she eats, it would be 1/2 plus 1/16, and then probably plus 1/128, since this is times 8, right? And then so on. And so note here, remember about the infinite geometric sum, like the sum of an infinite geometric sequence. So we know that that sum is A, which is the first value, divided by 1 minus R. And so we know that R here is 1/8, since that is how much is being times. So that means the sum is equal to 1/2 divided by 1 minus 1/8, which is 1/2 divided by 7/8, which is 1/2 times 8 divided by 7, which is 4/7. So that means the overall sum of the cheese that she eats is 4/7, which is A. Question 21. This school has assigned grades 1 to 7 to pods A through G, 1 grade per pod, and some of the pods are connected by walkways, as shown in the figure below. And the school noticed that each pair of connected pods has been assigned grades differing by 1 or more grade levels. Basically, grades 1 and 2 cannot be directly connected by a walkway. What is the sum of the grade levels assigned to pods C, E, and F? So we can start here by noticing that there's this pod here, pod C, and it has 1, 2, 3, 4, 5 pods that it's connected to through these walkways. So if we take this as our anchor for this problem, and we define C, the grade level, to be X, then we would have to mark out all the other ones. For example, B could be X plus 2, and then E could be X plus 3, and then this is X plus 4, and X plus 5, and X plus 6. And notice here you have to be aware that these two are connected, which is why I put X plus 3 here as opposed to here. So then, if we can just assume that it is 1, all we have to do is calculate each of these, and then we're able to find out the total sum of all of this. And so this is 7, and the remaining one is 2 here. So now we can just verify if all of these are correct. Yes, none of these are adjacent grades. So therefore, we get the final sum, which is 1 plus 4 plus 7, which is 12. So the answer is A, which is 12. Problem 22. A classroom has a row of 35 coat hooks, and Paulina hooks coats up so that there is at least one coat between them, at least one coat and at least one empty hook between each of the coats. How many different numbers of coats can satisfy Paulina's pattern? So what this means is, let's say X equals the number of coats, and then R equals the gap. X plus 1 times R equals 35. As note here, it tells us that before the first hook and after the last coat, before the first coat and after the last coat, there must be an empty gap as well. So if we kind of collect the terms here, we get R plus 1 X plus R equals 35. So since this is not a lot of numbers, we can do this thing where we just list out the complete number of possibilities. For example, X and then R. So let's say X equals to 1, then R would be 17. And if it's 2, it would be 11. If it's 3, it would be 8. If it's 4, notice here if X is 4, that would be 5R plus 4. And 31 minus 4 equals 35 minus 4 equals 31, which is not divisible by 5. So that's not correct. And then 5 is 5. 6 is also not correct. 7 is not correct. And then we look here, it's like, okay, there's a lot of gaps here. So on the X side, on the R side, so we can start using R as our anchor, and we assume like if R is 3, then we get 8. If R is 2, we get 11. If R is 1, we get 17, and then we have all of our answers. So now we count how many there are, and we'll notice eventually that there are 7 solutions to this. So our answer comes down to D, which is 7. Problem 23. How many 4-digit numbers have all 3 of the following properties? First, the tens and ones digits are both 9. And then it's 1 less than a perfect square, and the product is of exactly 2 prime numbers. Okay, so what this number is going to look like is likely it'll be like something like 99. And then if we add it up by 1, it'll be a number like 1600, 2500, all the way to 8100. So if we write this out, and we write them out using the perfect square that they have, it's going to be something like 40 squared minus 1 equals some like 2 numbers multiplied together. So now, Some people might know or recall a pattern of a squared minus b squared equals to a plus b times a minus b. Now this pattern is a common factoring trick, and it allows us to split up these like very large squares and their sum and their differences into two products, into a product of two numbers. So if we apply that pattern here, it's going to be 39 times 41. And then so on, we can write all of these down. It's 49 times 51. 59 times 61. 69 times 71. 79 times 81. And then finally 90 squared minus 1 equals 89 times 91. Now we just go through all of these and we see which ones are actually factors. So 39 is not a prime number since it's 3 times 17. 49 obviously isn't. This 59 times 61 is, so we can put a tick mark next to that. 69 is not, 81 is not, and 91 is not a prime number. So we know that there's only one solution here, so the answer is B. Problem 24. In trapezoid ABCD, angles B and C measure 60, and AB equals to DC. The side lengths are all positive integers, and the perimeter of ABCD is 30 units. How many non-congruent trapezoids satisfy all these conditions? So if we bring down the height here, since it tells us that the angle is 60, this will create a right triangle, and this forms 30 degrees. So we know that there is a pattern of triangles, which is the 30-60 triangles. And they have this pattern of 1, 2, and they have this pattern of 1, square root 3, and 2. So then, if we call this x, and then this will be y, 2x. And the same will apply to the other side of x and x. And the top and the bottom will both be y. So we can add this up, and then we'll get the total sum of 6x plus 2y equals to 30. Now we can simplify this by dividing both sides, which gets 3x plus y equals 15. Now since 15 is a relatively small number, we feel like safe to just write out another table. So x and y. Now first we can try if x equals to 1. That would mean that y would have to be 12, and if x equals to 2, y has to be 9. If x equals to 3, y has to be 6. If x equals 4, then y has to be 3. So there, we get 4 different solutions, so the answer is E. Problem 25. Michaela finds out the possible ways to draw a path in a 5x5 diamond-shaped grid. And each path starts at the bottom of the grid and ends at the top, always leaving 1 unit northeast or northwest. So she wants to find the area between the region of each path, which is the path and the right side. So this is shown in the figure of the shaded area. So it looks like pretty difficult of this problem. However, if we look at what things we are actually given by this problem, we know, like in regards to area, we only know the area of this whole figure. So that means we want to somehow map the number of paths onto the area of the whole figure. Now if you notice here is that these paths, they will always have an opposite side here, like filling up the opposite area. So for example, for this path, the opposite side would look something like this. Now shown in the red path, the opposite side would be here. So what this means is that to find the total area of all the paths, all we have to do is find the number of paths divided by 2, and then times 5 times 5. So the number of paths we know is 10, choose 5. And the reason for this is that you have 10 total steps you're going to take, and 5 of them are going to be in the northeast direction, with the other 5 being in the northwest direction. So if we calculate this, it's going to be 10 times 9 times 8 times 7 times 6 divided by 5 times 4 times 3 times 2 times 1. And we can simplify this to get a final answer of 6 times 6 times 7 divided by 1, which equals 252. And if you're unfamiliar with this type of like combinatorics, I suggest you like Google it or find a tutorial and learn about like the permutations and combinations and the differences between the two. So then we calculate the final area, which is 252 divided by 2 times 25, which equals 126 times 25, which is 3,150. So we know the final answer is B, which is 3150. So yeah, that's the end of our tutorial today. And if you're interested in other problems or you have any questions, just leave a comment below and I'll try and reach out to all of you. Bye bye.